Hello, chaps. Let's start off talking a little bit about a brief and incomplete history of the philosophy of science. Use that as a part, as a pretext to your readings. That might give you a decent idea of what we're embarking upon as you go through the readings and as you even plan on crafting your own research over time. So the oldest bit comes from Plato. Of course, you may have heard of Plato because he is the father of philosophy. And Plato in his own time talked about that, we talked about epistemology, which is basically understanding the linkages between the pieces that make up your ontology. So the epistemology basically denigrated scientific knowledge and said that you really don't know what's happening just by observing, because reality is merely shadows in the cave. It's a story about where a lot of people are all shackled in a cage and they have a fire burning and they see shadows of animals in front of the fire, but the shadows are coming from behind them. They've never actually looked at these animals, they've only seen shadows, and they've created metaphors for them. And oftentimes, the empiricist idea of observation-based reasoning is based on the fact that, well, are all observations right? You see the same story when you look at things like, the cigarette and tobacco stories, or stories related to marijuana. Some groups say yes, it's all right. Some groups say no, it doesn't harm. So the question is, both are observations, which one's true? So Plato said that, well, let's not even worry about observation. At the end of the day, what we assume as reality is what we think in the first place. And that actually makes a lot of sense, because this is beyond the shadows of the cave. This is the very fact that we deal with the moral and metaphysical structure of the universe. We come up with ideas that nobody ever had. And then if you were to ask yourself, where did I come up with that idea? Did I ask people? Did I inquire from someone? No. You came up with that idea based on your own logic. So that oftentimes becomes the centerpiece of the puzzle, which is you create your own universe. And then you try to test your universe later, but creating the universe doesn't automatically require you to observe things before moving forward. So this is called the knowledge of the forms, was to be gained not via observation and inference, but through pure reason and philosophical discourse. Reasoning is what makes you arrive at something. The very idea that, for example, nobody's really visited the Milky Way. Right. We live in a tiny, tiny, tiny corner of the Milky Way in a solar system, but we know about the Milky Way. We know about the birth and the death of stars. It's not because we've observed them, but we first came up with a theoretical inference that this is, I think, how it works. And based on that, we've gone out and searched for things. The same idea, nowadays you're planning to make landings on Mars, and landings on Mars are being successful with rovers and everything, but we never ever visited Mars, so we really didn't know what was in there, but we logically came up with the idea that this is what happens and this is how it's supposed to work. So the key issue is knowledge is gained not via observation but by pure reason. It is the basis for what we talk about as theories. Theories and conceptual models follow this Platonic perspective on building things. The next person, of course, is the very famous Aristotle. And Aristotle it's very interesting because Aristotle was Plato's disciple. He was his student, but he went exactly the other way. He came up with this idea of inductive deductive model that runs the gamut every place we go, right? So the inductive bit is looking at observed phenomena. So he went exactly opposite. He said everything is observation. Don't worry about what your mind tells you. Look at what you can find. You have to observe things, and that oftentimes has become a big part of the scientific discourse as we all know of it today. So, induction is when you look at an observed phenomena from which you try to create some general principles. So, you might look at an observed phenomena and say that, you know what, I understand then when a certain set is implemented, when a new person is recruited, when a new technology is put into play, when a new R&D innovation is released into the market, there appears to be tremendous amounts of energy around it. People tend to have a very high hope when a new idea comes forth. So if you come up with that hypothesis that a novel idea will increase the amount of interest in the market, you're basically talking about a general principle. From that general principle, now you'll try to observe the phenomena by looking at some real life examples of a new product being released. That truly, does it really matter? Do you really find a lot of interest coming through it? If that's the case, what you're doing is you're creating general principles that is instructing future observed phenomena, and this is called deduction. The other one is looking at observed phenomena. So you might look at how people get very interested in certain things. So perhaps you were out in the market and you were waiting and you suddenly heard that the new iPhone is coming out, or when the iWatch was coming out, you were at a market or at a mall, and you looked at the amount of interest, and from that you looked at an observation among people, and from that you said, you know what, I'm going to use that to come up with a theory and say that I have already seen people getting very interested in an iPhone, so I think that any kind of novel innovation is going to interest people. So one is looking at an observation first, from which it's coming up with a hypothesis. The other one is coming up with a hypothesis first with general principles, and then observing it to confirm or disconfirm the hypothesis. Now, most of our reasoning is a deductive reasoning. So most of the inferences we draw are deductive in nature. Not all are inductive. Sometimes they are inductive, but most of the time deductive. Hypothesis to confirmation. So from observation, one proceeds by inductive inference to general principles, which explain the observations in virtue of the fact that those same observations can be deduced from the principles, right? So this is the induction-deduction model, where the idea in induction is enumeration and direct intuition. So you look at something first, and then from that you enumerate and say that, well, if it happened here, it might happen everywhere. Deduction, on the other hand, is you come up with the overall logic first, from which you say that let's try and observe and see if things work that way. So once again, as I mentioned, deduction is the central idea behind how we run sets. So Aristotle required that the general principles be at least as evident as the observations. Ultimately, they should be self-evident or necessary truths. Now you'll hear this word self-evident, including if you read the Constitution, that certain truths are self-evident and inalienable rights. This self-evident basically says that the mind can decide what is good first before waiting for good or bad to happen. Because some things are true. People ought to be free. People ought to be given a chance to express themselves, and so on and so forth. So these are very important, but these are also self-evident. Now, that comes out of deduction. You come up with a general idea, And from that, you enact laws. And laws oftentimes are based on changes in reality, which oftentimes comes from observation, right? So the motivation here is to avoid arriving at claims which describe only accidental irregularities. So understand this. You're always trying to find a pattern. You're never trying to just look at an outlier, something that's happened in random, and say that, well, that's a pattern. No, something has to be repeated and replicable in order to actually create a pattern that creates a claim. So rather, these general principles should be evident, necessary truths reflecting the essences of objects and relationships in nature. Remember, we talked about epistemology. All that shows is the essence of objects and the relationships. And this is the issue of the law of nature. The problem is, of course, it's very hard to see how we can get to necessary truths via induction, because you can look at a single instance and then you can say that, well, we found it here, therefore it must be happening everywhere else. So let me ask you this question. If you look at Harvard Business Review cases, and where it talks about a single company, very well written, do you think that's inductive or deductive? Why do you think that's the case? So, Aristotle's four causes are, in order to make a proper claim, you must have a material cause. That is, it must be something that is changing, very much like a cause and an effect, something that changes its state, something that changes something else. There must be a formal cause, so there must be a reason why it changed. Was it because something else was introduced into the bit, a new employee, a new drug, or possibly a new idea, a new CEO? What is the formal cause? So what exactly is the cause? So what is undergoing the change? So you can say that, previously performance used to be this much, now performance has changed. What caused this change in performance? What's the most efficient cause? Which is, what are the things that we should look at as trying to figure out where the most important and the most efficient causes for that outcome? And finally, the final cause, which is the purpose or end for which the process occurs. So X occurs in order that, all right? So this says that you need to understand what is teleological in nature, right? So you have to realize that in order for something to occur, so once again, X occurs in order that something changes, right? So you have to understand what is the outcome or what is the cause. You also have to understand in the same bit, in order to understand a phenomena, if the phenomena and what you think of as a cause is correlated or caused. Now, if it's causal, then there must be a time difference between when something happened and when something changed. So simply put, the cause must occur prior to the outcome. If two things happen at the same time, there could be many other reasons because of which things are happening. So there might be something called an endogeneity. Endogeneity. Say you don't want endogeneity because that sometimes causes multicollinearity and spuriosity, because there might be other issues. You need to understand what's the cause. So whereas now we focus primarily on a combination of the first three and try to eliminate teleological explanation, Aristotle saw the final cause, teleological explanation, as the most important to understanding the nature of things. This raises the issue of nature of laws and causation. Now, you've all read Pythagoras' theorem, right? The very famous theorem in terms of a right angle triangle, c square is equal to a square plus b square, right? And you've heard of it several times. You know, he is a person who's extremely revered, mainly because he brought in mathematics as a mechanism to create relationships. That is there a mathematical, not only if there is a relationship, but is there a mathematical relationship? So the idea is, if you can find a mathematical pattern, you can find a consistent level of relationship between two objects. And this is in contrast to Aristotelianism, because it focuses on the formal cause to the exclusion of others. Because the whole idea is just look at the formal cause. You just want to know the formal cause. Everything has to have a mathematical set. But here's the interesting thing, especially if you're studying behavior or performance or similar things, especially in business and organizations. Mathematical precepts are wonderful in physics and chemistry and the hard sciences, but not in sciences where human beings, the environment, they're all involved, because there's no mechanism for you to know when things are going to change. So you really can't come up with a fixed mathematical relationship. You can't have a fixed beta. You can't have a fixed error term. You can't have a fixed intercept, an error term, a beta, which basically means that things change. Things change over time. So you really can't. So Pythagoreanism resembles Platonism, that the idea is everything can be expressed abstractly, but with a certain strong idea that's in your mind, very much like Plato, rather than Aristotle, who says observe everything every time and things might be different. But then the problem is we always know an answer, but we never know a universal answer. So understand that very well, and I'll leave you to mull about it, and I'll give you a reading. So let's call it a day till now, and when we meet next time, we'll talk more.